Hello students, welcome to the lecture number 17 of chapter 6. In this lecture we are going to discuss about two examples from that exercise, right? So let's start with the first example. According to the first example, it is given that if a transversal line intersect two lines, right? As you can see in the figure, there are two lines AB and CD, and a transversal line intersect these two lines at distinct point M and N. But it is not given that the line AB and CD are parallel. No, it is not given. Don't think that AB and CD are parallel. No, they are not parallel. Maybe they are parallel, but it is not given. Now, such that bisector of a pair of corresponding angles. Understand it? Pair of corresponding angles and its bisector. So first you have to find the pair of corresponding angles whenever a transversal line intersects any two lines at two distinct points, right? So you have to first find the pair of corresponding angles, then you have to find its bisector. Okay, so here in this side of the transversal line, this angle and this angle are corresponding angles. Okay, because they lie on the same side and they are non-adjacent. One lies towards the exterior side and one lies in the interior side. So these two angles are pair of corresponding angles. Now what you have to find? You have to find the bisector of such corresponding angle. I have told you what is an angle bisector. An angle bisector is a line. Okay, it is a line which bisect the angle or which divide the angle into two equal halves. If this is your 60 degree, then each sector will be 30 degree. Each half will be 30 degree. So this is the work of an angle bisector which divides the angle into two equal halves. Similarly, here you have to find the angle bisector of the pair of corresponding angles. Since the angle BMP and the angle DNM are corresponding angles, now let us find their angle bisector. Suppose this is the angle bisector of the angle BMP. Let the name of the angle bisector is MZ. Okay, so MZ is the angle bisector of the angle BMP. Now, since it is the angle bisector, so it divides the angle into two equal halves. Hence, you can write this angle is equal to this angle. That is why I use this symbol. Okay, to identify that these two angles are equal or these two halves are equal, and each half is the double of the total angle. Yes or no? See, if this is the angle bisector and the total angle is 60 degree and each half is 30 degree, then can you write the total angle is 2 times of the each half, or each half is equal to half of the total angle? Yes or no? Yes. Similarly, here also this half is the half of the total angle and this half is the half of the total angle. Understood? Now, this is the angle bisector of the angle DNM. Suppose the name of the bisector is NY. Right? So here the angle bisector is NY. Understood? So this angle bisector also divides this angle into two equal halves so that each half will be equal, and this is equal to half of the total angle and this is equal to half of the total angle. Understood? Now, what is given in the question? Now in the question is given that these two angle bisectors are parallel. Right? So according to the question, it is given that this angle bisector MZ and NY are parallel. MZ is parallel to NY. Okay, and now you have to prove that the two lines are parallel. Which two lines? These two lines, AB and CD. So you have to prove that AB is parallel to CD. Okay, so this is the basic of this question. You have to first understand it clearly. According to the question, it is given that there are two lines AB and CD and there is a transversal line PQ, right? Then we have two pair of or two corresponding angles. Now we draw the angle bisector of such corresponding angles MZ and NY. According to the question, these angle bisectors are parallel, and you have to prove that this line is parallel to this line, AB parallel to CD. Understood? So let us prove. So first we have to write what is given in the question. Okay. So it is given that AB and CD are two parallel lines and PQ is the transversal line. Okay. Now this angle and this angle are corresponding angle. So BMP and DNM are corresponding angle. Understood? MZ is the angle bisector. MZ is the angle bisector of which angle? Of BMP angle. Yes or no? Yes. Then you can write that this is equal to half of the total angle, or this is equal to half of the total angle. Okay. So you can write BMZ is equal to half of the total angle BMP, or this angle ZMP is equal to half of the total angle BMP. Understood? Next, here these two can be cross multiplied. Here 2 is in the denominator. Whenever you taken this 2 into the left hand side, then it will be multiplied with the left hand side. So it will be 2 of, or 2 times of BMZ is equal to BMP. Understood? Similarly, when this 2 goes to the left hand side, it will be multiplied 2 times of ZMP is equal to BMP. Okay? Right? So next, similarly, NY is the angle bisector of the angle DNM. Okay? So NY is the angle bisector of DNM. So you can write this angle is the half of the total angle, or this angle is the half of the total angle, because these two halves are equal. So you can write DNY is equal to half of the total angle DNM, or this angle YNM is equal to half of DNM. Okay? So next, you can cross multiply so that you will get 2 times of DNY is equal to DNM. Actually, it is not needed. It is not needed to cross multiply 2, but you can do it. Or 2 times of YNM is equal to DNM. Okay? So these two conditions we get by the angle bisector MZ and NY. Right? Next, how can we prove that AB line is parallel to CD line? This is the given section. Right? Now you have to prove what? You have to prove AB is parallel to CD. Now the question is, how can we prove that AB and CD are parallel? Remind exam 6.4. According to the exam 6.4, if a transversal line intersects any two lines at two distinct points so that the pair of corresponding angles are equal, then the two lines are parallel. Right? So in order to prove that these two lines are parallel, we have to first show that the corresponding angles formed are equal. Similarly, here in this case also, in order to prove AB is parallel to CD, we have to show that their corresponding angles must be equal. Okay, this angle and this angle are corresponding angle for the line AB and CD and transversal line PQ, right? So you have to first show these two angles must be equal. Then you can say yes, AB line is parallel to CD line, right? So let us prove. So our target is to show that these two angles must be equal, right? So in order to prove it, we have to erase this thing. You can take it as screenshot. Okay. So proof. Since this MZ is parallel to the line NY, MZ is parallel to NY. This is given in the question, right? Now you do one thing, extend it in this direction and extend it in this direction. Okay, so this line is parallel to this line, right? And this is the transversal line. Forget about AB and CD. Forget about AB and CD. Only consider this line. Okay, suppose this is your MZ and another line NY. Okay, and PQ is the transversal line. Forget about AB and CD. These two lines are parallel. It is given in the question. Now, whenever this transversal line PQ intersect these two parallel lines, then these two angles are known as corresponding angles, and according to the axiom 6.3, if a transversal line intersect any two parallel lines, then their corresponding angles are equal. So here also, see, this is the line and this is the line. This is the transversal line. So which two angles are corresponding? This angle and this angle. See, this angle and this angle. Now to clear conceptual clearance, I have omit AB and CD here so that you can easily understand which two angles are corresponding. So these two angles, that means this angle and this angle, are corresponding angle, right? So you can write that the angle ZMP is equal to the angle MNY, or you can say YNM. Okay. So next, then see, this is the angle bisector of this angle. Then this is the half of the total angle and this is the half of the total angle. We have written here, but I have erased it. So it is ZMP is the half of the total angle, half of BMP, okay, and this angle ZMB is the half of the total angle. We have erased it, okay, here it has been written. Now cross multiply, so the 2 will be multiplied. 2 of ZMP is equal to BMP, or 2 times of ZMB is equal to BM. Okay, so we have already get it from the given section, right? Now you have find that ZMP angle is equal to Y and M angle, right? Now you will multiply 2 in both the sides, okay? Multiply 2 in both sides, so that it will be 2 ZMP and it will be 2 YNM. Right? Next, see one thing here. 2 times of ZMP. 2 times of ZMP is equal to how much? Is equal to BMP. Right? So in the place of 2 ZMP you can write BMP is equal. Then 2 times of Y and M. See here. In the place of 2 times of y and m, you can substitute d and m angle. D and m angle. Okay, so here you multiply 2 on both the sides. So finally we get that the angle BMP, that means this total angle is equal to the angle DNM, that means this total angle. So finally we find that these two angles are equal. And which type of angles these are? These are corresponding angles. Okay, but these are corresponding angle. Hence, what we can write? We can write that this line is parallel to this line. Why? Because according to the axiom number 6.4, we know that if two corresponding angles are equal whenever a transversal line intersects any two lines at two distinct points, then these two lines will be parallel. So you can write hence AB is parallel to CD due to axiom 6.4. Hence it is proved. Okay, maybe it is confusing because I have erased this thing. Okay, that's why I written it twice. Okay, then you can use this two concept in order to find that this corresponding angle is equal to this angle. Hence you can write this line is parallel to